Welcome to Review Recording 1C-D, which accompanies instructional recordings 1C and 1D for Section 3.4, Unit 3, Chapter 3 of Mathematics 2200. We're going to do a couple of examples on solving problems involving quadratic functions. Example 1. A theater seats 2,000 people, and when it charges $10 per ticket, all tickets are sold. A survey indicates that for every $2 increase in ticket price, the number of tickets sold would decrease by 100. Which equation could be used to determine the ticket price that results in the greatest revenue? And note, N in this problem represents the number of $2 increases. Recall, revenue is equal to the number of items sold or expected to sell times the price per item. Now in this problem, the revenue is represented by Y. Now we got to think carefully about the number of items sold. If we increase the price once, we will have 100 fewer tickets sold. If we increase it twice, it'll be 100 times 2. If we increase it 3 times, it's 100 times 3 fewer. And if it's N price increases, then we'll have 100 times N fewer tickets sold. Meanwhile, the price per item, the original price was $10. And we are adding $2 each time we increase the price. So if we increase it once, it's one increase of $2, or 2 times 1. If we increase it twice by $2, that's 2 times 2. If we increase it 3 times by $2, it's 2 times 3. If we increase it N times by $2, then it's 2 times N. So our total price per item is 10 plus 2N. So the correct function is 2,000 minus 100N times 10 plus 2N equals Y, which is our revenue. That means B is the correct answer. In example 2, a rectangular swimming area consisting of equal area sections for tots, water sports, diving, and relaxation is marked off in a pond using 600 meters of rope. Create and use a quadratic function to determine dimensions, that is the length and width, that will give the maximum area for the entire swimming area. Now let's first off decide which parts get rope. Well, we're going to use rope to form this side and this and this and this and this, plus all of this side and all of this side. So we have 5 W's taking up rope. And I could call these little pieces L's, but it's a little easier, I think, to call this whole side L, because we want the entire swimming area, that whole big rectangle, to be maximized. So we have L there and L there. Therefore, 2L plus 5W gives us 600 meters of rope. We can rearrange that one to get L by itself. 2L equals negative 5W plus 600. Divide by 2. And we have L is equal to negative 2.5W plus 300. Meanwhile, we want to maximize the area. So the area of the whole swimming area is equal to the length times the width. We can use this expression for L and substitute into the area formula. So we have negative 2.5, negative 2.5W rather, plus 300 times W. Just draw an arrow there to show my order of steps. and we've got A equals negative 2.5 W squared plus 300 W when I distribute that W into those two terms. Now we're only asked for the dimensions that will give the maximum area. We're not actually asked to get the maximum area. So negative B over 2A, that'll give us the width. That gives us the maximum area. So it's negative B over 2A, that's negative 300 over 2 times negative 2.5. That's negative 300 over negative 5, which is positive 60. So we know the width is 60 meters, and therefore the length, using this expression back here, negative 2.5 times 60 plus 300, that gives us 150. Therefore, our maximum area is obtained when the width is 60 meters and the length is 150 meters. In conclusion, maximum revenue problems, choose a variable to represent the number of price increases. Write an expression in terms of the variable for the number of items sold and one for the price per item. Use this relationship to get the quadratic function. Then expand, find the vertex, and interpret it. Didn't have to do that in our multiple choice problem, but it is something you should be aware of. For area problems, sketch a diagram, determine which sides of the diagram will actually use the material. Write an expression relating the sides using material to the amount of material available and solve it for a variable. Write the formula for area and use step 4 to replace a variable. Expand, find the vertex, and interpret it.